Hi everyone. We're going to continue our discussion on functions. We're going to look at how we can restrict the domain of a function. Okay, sometimes for whatever reason you might like to restrict the domain. Maybe if you're doing an application style question and the entire domain of what you might normally have for a particular kind of function isn't really relevant to that situation. Okay, you'll see that later on when you do application style questions in this chapter and later chapters. Okay, but sometimes we want to restrict the domain ourselves rather than using the largest possible domain, which is what we call the implied domain. Okay, so here's an example. So we've got the function f of x equals x squared, and according to the function definition in the notation, the domain would be all real numbers. Okay, and if you were to sketch a graph of this function, it's just a normal parabola. Okay, and the main thing here is that you note that the parabola goes on forever in both the positive and negative x directions because the domain is all real numbers, so you draw it for forever. Sometimes you might like to restrict the domain though. So let's consider another example where we're only considering positive x values. Okay, so positive x values means your x values start at 0 but not including 0 because it's not positive, and they move on forever to positive infinity. Okay, so one way you could write that would be x greater than 0, or you could write it as 0 comma infinity, or you could write it using the symbol we've got here, r with a superscript plus. That means positive real numbers, or all the numbers between 0 and positive infinity, not including 0. What would that look like if you were to draw a graph of this? Well, it's just the right half of that parabola. Okay, I drew this on Desmos, and Desmos isn't really good at showing endpoints. So what you would do is when you sketch something like this, 0 here is what we call an endpoint. Okay, it's the point where you end drawing your graph. All right. Now, according to our domain, the x value of 0 is not included in our drawing of the graph because we are only considering positive x values. Our domain is positive real numbers, and that excludes the number 0 because 0 is not positive. So when you sketch this stuff yourself, you've got to make sure that you draw like an open circle. I'll make it a bit bigger. An open circle here at 0 to indicate that that point is not included on your drawing of the graph. Okay? So, sometimes you want to restrict the domain. That means your graph is going to be drawn differently than it normally would if you didn't restrict the domain. Okay? So let's have a go at sketching some restricted functions. Now, some steps that you can follow to make this slightly easier for yourself are as follows. First of all, find any x and y intercepts as well as any other important features. Okay, so things like turning points, stuff like that, maybe some asymptotes as well if you've got that kind of function. Do that for now. Okay, even though you might not actually draw them because they might not be included in your domain, it's still good practice, at least for now, to find all these important features. Okay. Once you've done that, determine the endpoints of your graph by substituting the endpoints of the domain into the function. Okay, we'll see an example of that in a second. Once you've found your endpoints and you know what your graph looks like, you just sketch your graph like you normally would. The only difference here is you're only sketching a graph between the endpoints. Everything outside of your endpoints doesn't count because it's not part of your domain, so it shouldn't be part of your sketch. Then finally, just double check whether the endpoints are included or not. Okay, if they're included, you draw closed circles or filled in circles. If they're not included, you draw an open circle like we did on the last slide. Okay, that's your sort of basic step-by-step instruction. So let's do some examples. All right, so with the first one here, What you should be able to do by now, hopefully, is recognize that this is the equation for a straight line. Okay, it's got a gradient of 2 and a y-intercept of -1. Okay, so that should be pretty apparent by now, hopefully. If it's not, then you need to go back and review those things. Our domain here is restricted. It's not all real numbers like it normally is. It's between -2 and 3, including -2, not including -3. Oh, sorry, not including 3. So let's have a go at sketching this. So first we'll set up our Cartesian plane. All right, let's find our critical pieces of information. So intercepts and endpoints. So we already know that the y-intercept is going to be -1, so we can pop that in. Use another color. So -1 would be here. All right, what would the x-intercept be? Well, how do you normally find x-intercepts? You make y equals 0. So you find your x-intercept. You make y 0. In this case, this f of x thing here, that's equivalent to y. So you go 0 equals 2x minus 1, 2x equals 1, x equals half. There we go. So that's our x-intercept. All right. What are our endpoints? So to determine your endpoints, you need to substitute in the endpoints of your domain into your function. So our endpoints are -2 and 3. So let's do -2 first. So f of -2 equals 2 times -2 minus 1. 2 times -2 is -4 minus 1, -5. Okay, so that's our left endpoint. Our right endpoint, well, we substitute 3 into that. You get f of 3 equals 2 times 3 minus 1. 2 times 3 is 6, minus 1 is 5. Okay, so there we go. Those are the coordinates of our endpoints, -2 and -5, and 3 and 5. Okay, so now all we've got to do, sketch our graph in between those endpoints. So let's say -2 is here. Let's say 3 is here. It's going to be a weird looking drawing. It's going to be something like that. Okay, good enough. All right, and you put in your endpoints. So we're not including this endpoint here, so don't include that. That's an open circle. We are including this endpoint here, so color that in, and then just label your endpoints with their coordinates. So that would be 3, 5. That would be -2, -5. And that's it. That's your sketch of that function. Okay, so it is a little bit lengthy, the process. So you really have got to make sure that you understand the shapes of your graphs, given the rule. You've got to understand how to find your intercepts, and you've got to understand how to find your endpoints. Okay, let's move on to the second one. So we have this function here. It's called g. G of x is equal to x squared, so that's just your regular parabola with the vertex at 0, 0, turning point at 0, 0. Okay, however, the domain is now from -∞ to 3 rather than -∞ to +∞ like it normally is, okay, or all real numbers. This has been restricted. So let's start by just drawing our Cartesian plane. Okay, now we don't really need to worry about our x, y intercepts and turning point because we should already know that that's all happening down here at the origin. Okay. However, we still need to determine our endpoints. Okay, now you can't figure out an endpoint for infinity because that goes on forever, but we can work out the endpoint for 3. Okay, so what we do is we substitute 3 into our function. F of 3 equals 3 squared equals 9. Okay, so that means we're going to have an endpoint somewhere at 3, 9 up here. Okay, the only problem is we're not including the 3 in our drawing of our function, so we have to draw an open circle at that point. Okay, And then you just sketch your function like you normally would. So it's a parabola, comes in like that, vertex at 0, 0, goes up and stops at 3. Okay. Label your endpoint, 3, 9. You might want to put an arrow there just to indicate that it does go on forever. And that's it. That's your drawing. Okay. So make sure you follow that list of steps that will aid you in drawing these restricted functions. Okay, so we'll stop there, and I'll see you in the next video.